I think they'll get left behind if they don't do this. We've had our first public event was probably the New Worlds Conference in Austin. That was in November. And at that point, a lot of the NASA folks, a lot of the space folks were not really immediately grasping the utility of edge compute in space. Like, what can you do with powerful processors in space? Who is your customer? What is your use case? And, we had to lay that out for them. And this was, 6 months in, so our cases were not as sophisticated and as well laid out as they are today. I'd like to say that repeats itself in 6 months as well, because you always want to be growing, you always want to be learning, you always want to be coming up with new stuff. So we had to really explain to them the utility of it. And then recently, like a month ago, we went to a NASA event in Tampa, and we talked about that, and the response had really advanced. People were, regular NASA folks were saying, "Oh yeah, this is essential. We need this piece of infrastructure. This is something that we're lacking." It had gone from what is the benefit to this to yes, please. Right. And that's really, I think everybody in the space industry has had to undergo some sort of an internal paradigm shift over the past 6 months, maybe. I'm seeing a lot more optimism for the future. I'm seeing a lot more willingness to entertain big plans than I was a year ago. There was stuff that you could have said a year ago that would have not gone over well. And today, very serious people are talking about it, and they're writing papers on it, and they're seeking funding on it, and funding is getting released for things that were Buck Rogers just a little bit ago.
Interesting culture shifts and optimism and that, and it's being able to say stuff that would be laughed at or dismissed a short time ago is really weird. Yeah, it's like a strange thing. So let's talk about those customers and what they're going to get out of having OrbitsEdge technology up there. Beyond data transfer and speed to insight, we have a data science department, so that stuff's important to me. What other savings or advantages will customers experience?
So part of it is what we can do in terms of analytics of space data. A lot of that is going to be Earth imaging, and that moves into multispectral and multiple images over time. Those are some of the greatest amounts of data that are generated in space. So those, in those cases, we can better utilize the observational assets to have basically better quality data down. We can perform analytics to not only assess quality of the images and throw out bad ones, but also find out patterns that are of interest to the user. There's a very simple version, a very simple description of a process that we could do. As you go over the ocean, most of the ocean is ocean, and a very small fraction of that is ships and whales and oil slicks and things that are not ocean.
Right.
You could have a relatively simple AI that sorts those things out and sends down everything that's not ocean, and along with perhaps metadata about the ocean that it does pass over. Right. So in that case, you would have a lot of data that is of use, of potential use, and you would not have the data that is essentially lots of noise. And you would even get some data about that data, which would be very useful. Now, in addition to that, we can do things like run AIs, and we can do machine learning. We are going to be a smart platform. I mean, we're going to have more compute on each of our satellites than what's been up there ever before. And we can utilize that capability to improve the efficiency of our own operation as well as for other people. And this allows things Like it facilitates refueling, it facilitates satellite repair, because that's going to be a fairly complicated process. Anything where you require some degree of autonomy on the part of your satellite,
Right.
that's going to require compute. And as we move farther away from LEO, as we move to cislunar space, and we have Artemis coming on,
Mm-hmm.
that's going to require a significant amount of compute too, because the farther away you get from Earth, the bigger a deal latency becomes. And just having a teleoperated radio control robot is not going to cut it.
Yeah, and that is something that people are quick to forget. By the time we get colonies on Mars, it's going to be back to the age of telegraph again.
It is.
For
It is. It's going to be. It's going to be carrier pigeon. I mean, I can send a video to you, and then later in the day, I'll maybe have one back.
Right. Right. It ain't going to be this way, folks. More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago, and the second best time is today. This is Jason Kanigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.